All right, guys, back again, back to the ambiguous case of the law of sines. Okay, so let's see what we got going on here with this guy. Okay, so I have triangle ABC and I know angle A. Okay, so again, I'm going to use a very similar type diagram that I was using yesterday. And let's see what's going on. Okay, so I have angle A here, okay, which is 40 pesos. Okay, little a is opposite that, so this is little a over here, and that's 20 units. Okay, and I don't know whether or not I can form a triangle, or if I can, it's only going to be one triangle, or if I have two possible triangles. Okay, I have little b. Now remember, we have to have side angle, so little b has to be right here, and that's 15. Okay, so point, if we have a triangle, point B will be down here, okay, opposite little b. So odd man out, that puts C there, so little c's down here. Okay, and we'll see what happens. Now, I'm going to be referencing that sheet in the notes that I talked about in the previous video. So the very first thing we have to do is look at our height and see whether or not we can even form a triangle. Okay, so remember, your height will always, I'm sorry, I'm writing a B there, I meant to write an H. Sorry about that, guys. Okay, our height will always be little b times the sine of angle A. Okay, so little b is 15 times the sine of 40. Okay, angle A is 40 degrees. And so we punch that into our calculator. Just get out your Walmart special. Okay, and so we have 15 times the sine of 40 degrees. Okay, and I am getting 9.64 when it's rounded off. Okay, so this guy is roughly 9.64. So notice that little a, okay, is 20, so it's definitely longer than 9.64. Okay, so A is greater than H, so that means we can definitely form a triangle, but notice that A, okay, is greater than B. A is greater than B, okay? So that means if I take A and try to swing it back over here, I'm gonna have to swing it all the way past, okay? So I can't form a second triangle, okay? So we have A is greater than B. So it looks like we're just going to have one triangle here, okay? Because A is greater than B. Okay. All right, so this means right here we have one triangle. And again, I'm referencing that sheet that we talked about yesterday, not only the sheet that's in the notes, but obviously the notes that we talked about, okay, to outline this stuff. Okay, so let's see what we have. We only have one triangle, okay? I only got one. Okay, this guy's going to look something like this, I guess. I don't know. So I got A here, I got B here, I got C here. I have my little b is 15. Okay, my little a is 20. Okay, and we have 40 degrees here. Okay, so I use the law of sines. Okay, so I say the sine of angle A, which is 40 degrees, over the length of the side opposite, little a, which is 20, has to be equal to the sine of angle B, which I do not know, over the length of the side opposite, little b, which is 15. And that equals the sine of angle C over the length of the side that's opposite. And I don't know that. I could call that little c like that, or I could just call it AB. I'll call it AB. Okay, so let's see what we got going on here. Here's my cornerstone again, because I know both the numerator and the denominator. Okay, notice all the way over here, I don't know angle C and I don't know AB, so I can't set this guy equal to that guy because I have two unknowns. Okay, but I can set this guy equal to this guy because I only have one unknown, the measure of angle B, so we'll start there. So the first thing I do, the sine of 40 degrees over 20 equals the sine of angle B over 15, and then I take my cross products. So I have 20 times the sine of angle B equals 15 times the sine of 40 pesos. Divide by 20. So the sine of angle B will be 15 times the sine of 40 pesos, all divided by 20. Okay, now I need the measure of angle B. Okay, so I have got to take sine inverse to get the measure of angle B. Okay, so the measure of angle B will be sine inverse of this entire thing. Okay, so I'm going to definitely want to make sure I punch the whole thing into the calculator at once. Okay, so I definitely want to separate that numerator from the denominator. Okay, so I'm going to say 15 times the sine, and I'm going to get parentheses for the 40, so I need a second set of parentheses to separate the numerator from the denominator, so that'll be 20, and then I can just punch it in. Okay, so let's see, it's in degrees, so second sine inverse, okay, of 15 times the sine of 40, and I would have 1, 2, okay, divided by 20, parentheses. I am coming up with the measure of angle B is 28.82 when it's rounded off. Now I'm going to check that one more time to make sure I got it right. So let's see, second sine inverse, so that first grouping symbol is this guy, so I need a second grouping symbol. 15 times the sine of 40, and so I need a grouping symbol right here for the 40, so I need another grouping symbol for the numerator, and then divided by 20, and a second parenthesis. Okay, there we go. Hit enter, and again it's coming out to 28.82, so I should feel good about that. So let's see, this guy is 28.82 pesos. Okay, so I have to find the measure of angle C. Second thing, okay, measure of angle C. Now notice the only way I can find that is to use the triangle sum theorem. Okay, so I've got to go 180 minus the 40 minus the 28.82. 180 minus 40 minus 28.82. Okay, so let's see. 180 minus 40 is 140, so 140 minus 28.82. I'm coming up with 111.18 pesos. So that guy, 111.18 pesos. Okay, I'll check that one more time just to make sure it's good. 180 minus 40 minus 28.82. Yeah, 111.18. So I feel pretty good about that. Okay, so the last thing I have to do is find this AB. So I can set the cornerstone equal to this, and we now know a good approximation for the measure of angle C, so we can solve for our missing side length. Okay, so let's see, the sine of 40 over 20 equals the sine of angle C, which is 111.18, all over our missing side length, AB. So taking your cross products, we get AB times the sine of 40 equals 20 times the sine of 111.18, and then I would just have to divide by the sine of 40. Okay, so AB is 20 times the sine of 111.18 pesos, all divided by the sine of 40. And then let's see, I'm going to punch it all into my calculator, so I need to separate that from this. Okay, I know my calculator will generate that, so I need a second one. Calculator will generate that, so I need a second one. So I'm going to punch it in. Okay, so I have parenthesis 20 times the sine 111.18, second parenthesis for the angle measure, second parenthesis for the numerator, divided by parenthesis for the denominator, sine of 40, second parenthesis for the 40 degrees, and second parenthesis for the denominator, and hit enter. And I'm coming up with 29.01. Okay, I'm gonna check that one more time just to make sure. So I have 20 times the sine 111.1812 divided by sine of 40 with two parentheses, and I am getting 29.01. So this guy right here is approximately 29.01. Okay, so I have that triangle solved. We're in good shape there. Okay, let's see if we can get another one in. Little A, B. Okay. 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 All right, let's take a look at this guy. Let's see what happens. Again, I'll start up top just like I did with the last one. Okay, I'm going to make a little drawing, very similar. I'm going to put my A right here because I know that guy. The measure of angle A is 50 degrees. Okay. Little a is opposite that, and that guy is 10 units. Okay, little b has to be adjacent to a because I need side angle. Okay, so this is my little b, which is 20. Okay, if little b is here, then that means if I can form a triangle, vertex B would be here, and obviously odd man out, vertex C is there, and little c is here. Okay, very first thing I have to do is check the height. Can we form a triangle? Okay, so remember your height always ends up being little b times the sine of A. Okay, so we get little b, which is 20, times the sine of angle A, which is 50 pesos. Okay, and I punch that in and compare it to little a. Okay, so 20 times the sine of 50, and I am getting 15.32. Okay, so this guy is 15.32, and I compare that with little a, and notice that A is less than H. Okay, so that means that A can't even reach down and form a triangle. Okay, so this guy right here, no triangle. So that means obviously there's nothing to solve. Okay, and so we've always got to check, very first thing, can we even form a triangle? Clearly you can't form a triangle there, so there's no triangle to solve. Okay, let's see if we can get another one out of the way. Okay, let's try this guy. Okay, same setup. Draw my diagram. Okay, I know angle A, so I'm going to put that right there, and that's 75 pesos. Okay, little a is opposite angle A, so little a is 51. Okay, little b has to be adjacent to the angle I know, to angle A. Okay, it needs to be adjacent because I have side angle. Okay, so b is 71. Okay, and then let's form our height. Okay, so the very first thing we have to do is calculate the height, and let's see whether or not we can even form a triangle. Okay, so remember your height ends up being b times the sine of angle A. Okay, so we get little b, which is 71, times the sine of angle A, which is 75 pesos. And we punch that into our calculator. 71 times the sine of 75 pesos. And I am getting 68.58. Okay, so it looks like our height is 68.58. Okay, so let's make sure we have that set up again right. okay, 75 degrees. Little a is 51. Little b is adjacent to angle A, and that's 71. Okay, so obviously B would, if we could form B, it'd be down there. C would be up here. Okay, so my height, okay, has to be little b times the sine of A. So we get 71 times the sine of angle A, which is 75 degrees. And notice again, we get the height, okay, is greater than A. Okay, so we get A is less than H. Okay, so that means that A cannot even swing down and form a triangle. So once again, we get no triangle. So again, just like the last one, there's nothing to solve, okay, because you can't form a triangle. Okay, all right, that's sort of anticlimactic. Okay, let's see if we can get another one in. Those two are certainly pretty easy. Okay, so let's see what's going on here. Okay, let's see. All right. Once again, I'll start it the same way. Okay, I know angle A, and that's 40 pesos. Okay, I know little a is opposite that, that's 54. Okay, little b has to be adjacent to angle A. Once again, because I need side, angle. Little b is 62. Okay, so if little b is here, if we can form a triangle, vertex B will be here. And by odd man out, that'll be vertex C. So obviously this is little c. So once again, we look at our height, and we got to figure out what that height is. Okay, so our height ends up being little b times the sine of angle A. Okay, so little b is 62 times the sine of angle A, which is 40. Okay, so we go to our Walmart special, and we go 62 times the sine of 40, 4140. Okay, and I'm getting 39.85. Okay, 39.85, yes. Okay, 39.85. So notice that A is greater than H. So that means that A can reach down here, okay, and form a triangle. Okay, A is greater than H. So now it just comes down to, can we form one triangle or two triangles? Okay, so let's see. A is 54, and it's less than B. Okay, so A is less than B. So that means I would have one triangle here, okay, and then I could swing that over here and form another triangle. So I get two triangles. So this is the ambiguous case, okay, where we get two different triangles. Okay, so let's see what happens here. Okay, I'm going to get one triangle that looks similar to this guy. Okay, so I got an A here, I got a B here, I got a C here. Okay, my little b is 62, my little a is 54, okay, and my measure of angle A is 40. Okay, that's my first triangle. Now my second triangle will look different because I can take this little a and I can swing it over. Okay, so bring this guy and swing it over. Okay, so we're going to have something that's going to look like this. Like this. Okay, so you still have the 40 degrees there with A. This is still 62, and this is still 54. Okay, that's C and that's B. Okay, so let's see what happens here. Okay, I'm going to start with this triangle right here. Okay, and so we have the sine of angle A, which is 40 pesos, over 54, equals the sine of angle B, which I don't know, over little b, which is 62, equals the sine of angle C, which I don't know, over the side that's opposite, little c, or AB. I'll call it AB. Okay, so if I take this ratio and set it equal here, I can solve for the measure of angle B. Okay, so first thing I do, sine of 40 over 54 equals the sine of angle B over 62. Okay, I take my cross products. Okay, so I get 54 times the sine of angle B equals 62 times the sine of 40. And then I divide by 54. So the sine of angle B equals 62 times the sine of 40, all divided by 54. And so I want the measure of angle B, so I use sine inverse. So the measure of angle B equals sine inverse of this entire ratio. So I separate the numerator from the denominator, so I'd have 62 times the sine, and that parenthesis pops up, 40, second parenthesis for the 40, and then a second parenthesis for the numerator, all over 54. And I punch that in. Okay, so let's see. Second, sine inverse. Okay, that first parenthesis pops up, takes care of the bracket, so I need a parenthesis, 62 times the sine of 40, second parenthesis for the 40, second parenthesis for the numerator, divided by 54, and then my bracket. I am getting 47.56 pesos. Okay, so let's see the measure of angle B. So that would be 47.56 pesos. Okay, now I can find the measure of angle C. So the measure of angle C is 180, using the triangle sum theorem, minus the 40, minus the 47.56. Okay, so let's see. 180 minus 40 is 140, so 140 minus 47.56. I'm coming up with 92.44 pesos. Okay, so this guy right here, 92.44 pesos. Okay, so now I can find this missing side length. Go back to my cornerstone ratio, sine of 40 over 54 equals the sine of angle C, which is 92.44, sine of 92.44 over my missing side length, AB. Okay, so take my cross products. Okay, so I have AB times the sine of 40, okay, equals 54 times the sine of 92.44, and then I have to divide by the sine of 40. So my AB equals, and I'm going to separate the numerator from the denominator with grouping symbols. So I'd have 54 times the sine of 92.44, and then a second parenthesis to separate the numerator, divided by the sine of 40 in my second parenthesis for the denominator. Okay, and so we will punch that in. Okay, so let's see, I have parenthesis 54 times the sine of 92.44, 92.44, parenthesis for the 92.44, then second parenthesis for the numerator, divided by parenthesis sine of 40, second parenthesis for 40, and second parenthesis for the denominator, and hit enter. And I'm getting 83.93 when it's rounded off to the nearest hundredth. So this guy would have to be 83.93. Okay, let's see if that makes sense. Okay, notice the largest of the three angles is angle C, and it's opposite the longer of the three sides, so that's good. The smallest angle of all three is angle A, and that's opposite the shortest of the three sides, and then angle B and the side opposite are in between, so that makes sense. Okay, so that's good. All right, now, let's take a look here. How do we get over to here? Okay, let me bring a piece of paper over here. And let's go back to this original guy. Okay, so let's see. We've got this guy right here, this original triangle that we were just working with. Okay, I've got A here, I've got B here, I've got C here. Now we know that we're gonna take this side, okay, this little a right there, we're gonna take this side and we're gonna rotate it over. So this guy is gonna rotate over to form another triangle, just like this guy. So I got this guy and this guy. Now I know that this is congruent to that. Okay. All right, so I know that this angle right here is 47.56. Now notice that this triangle here is an isosceles triangle. I get two congruent sides. Okay, so this angle has to be 47.56. Okay, now this angle right here is this angle right here. Okay, so wouldn't these two angles have to be supplementary because it's a linear pair? So wouldn't this guy right here have to be 180 minus 47.56? Okay, so the measure of angle B must be 180 minus 47.56. Okay, so I figure that out. 180 minus 47.56, and I get 132.44 pesos. Now this is really important. This guy right here and this guy right here, from the two different triangles, they will always be, always be supplementary. Okay, so once we find angle B over here, we always subtract it from 180 to get angle B over here. Okay, that's going to happen 100% of the time. Okay, I like that guy. All right, so let's see. We found angle B. Measure of angle B here is 180 minus 47.56, so we came up with that 132.44 pesos. Okay, so now I can find the measure of angle C using the triangle sum theorem. So the measure of angle C is 180 minus this 40 degrees from angle A minus this 132.44 from angle B. Okay, so let's see. 180 minus 40 is 140, so I go 140 minus 132.44, and I get 7.56 pesos. So this guy right here is 7.56 pesos. Okay, so let's see. What else do I have to find up there? I have angle A, I have angle B, I have angle C, I have little b, which is the same as side AC. I have little a, which is the same as side BC. So I've got to find little c, which is the same as AB. Okay, now I would go back to my cornerstone, because don't forget, this is an approximation, and this is an approximation. So I wouldn't use those to find a missing side length unless I was forced to. I would go back here, because I know 40 degrees for angle A is exact. Okay, so we get the sine of 40 pesos over the length of the side opposite, 40 degrees, which is 54. Now I'm looking for this little c down here, which is AB, so I have to use the length of the, the measure of the angle opposite that. So I'd say the sine of angle C, which is 7.56 pesos, over the length of the side opposite, AB. and I've got to solve for that. Okay, so let's see, cross products give us AB times the sine of 40 equals 54 times the sine of 7.56, and then we divide by the sine of 40. So AB equals, separate the numerator from the denominator, so 54 times the sine. I need two parentheses for the angle measure, and then a second parenthesis to separate the numerator from the denominator, all divided by the sine of 40. So parenthesis, sine of 40, second parenthesis to separate the denominator, and we punch it in. Okay, so we have parenthesis 54 times the sine of 7.56, parenthesis, divided by parenthesis, sine of 40, parenthesis, equals, I have 11.05. Okay, so that means my AB is 11.05. Okay, that is the ambiguous case where, given the information available to us at the beginning, there are two possible triangles, and we have to solve for both of them. Okay, I will come back tomorrow and we'll do another situation like this, because I know this is tough. I'm not trying to tell you this is easy. This is tough. Okay, so we'll do at least one more of these tomorrow. Okay, and we'll get it uploaded in video form. And don't forget that you have a quiz due next Monday. Okay, you will have to do this on the quiz. Okay, find a situation like this where we definitely know we have two triangles. You got to solve both of them. Okay, you want to make sure that you get that done on time. If you turn it in late, you're not going to get full credit for it, and it's going to be graded. It's not like homework where it's credit, no credit. It's a quiz. It'll be graded, so you want to do your best. Okay, you guys make sure that you stay safe, okay, and stay away from the zombie virus, okay, and I'll talk to you soon.